Short problems are not necessarily easy problems. We see a problem like this one that's only a few sentences. We assume, oh, this is going to be straightforward, but short problems can hide a lot. Let's take a look. The Kitty Cream donut production facility consists of 3 identical donut fry vats, each which operate at 75% efficiency last month. Okay, if the facility produced a total of 150,000 donuts last week, what is the apparent effective capacity of one of these Kitty Cream donut fry vats? Oh, now, this particular question is also a good example of a question in which you need to use a formula, but the question gave you the answer to the formula. The question is not asking for the result of the formula. The question gave you the answer to the formula. It's asking you to look for something else. Oh, now, all right, what's this formula that I'm talking about? It's efficiency. It said here that they're 75% efficient. Okay, so I'm just a note to myself, efficiency. Efficiency is, this is the formula, output over effective capacity. Right? Now, this problem gave us the efficiency. It said this all equals 0.75. Done. The problem is asking about effective capacity. That right there. The problem also tells us about output, right? This total of 150,000 donuts last week. Oh, wait a minute. Okay, if this is an output for Kitty Cream, 150,000 donuts, right? That over effective capacity, I'm just filling in that formula, is apparently 0.75. Oh, I see how to solve for effective capacity. You solve for what's missing? Okay, so I can multiply both sides by effective capacity. I'm just going to treat this as an unknown right here, right? So that it would be 150,000 equals 0.75 times the effective capacity, or the effective capacity equals 150,000 divided by 0.75. Okay, 150,000 divided by 0.75. You might have gotten this. It's 200,000. Oh, all right. The effective capacity at Kitty Cream, answer the question, is 200,000 donuts. A lot of donuts. That's not actually the answer. Now wait, I solved for, I said, oh, this is the relationship. That's what it asked for, right? Solve for it. When you solve for that based on the total output, you get 200,000. That's not the answer to the question. Small questions can hide a lot. You have to search for it. What did the question ask? The apparent effective capacity, yeah, okay, with the 200,000 of one of their donut fry vats. What did it start out with? They have 3 identical donut fry vats, 3 of them. This 150,000 donuts in output is the output of all 3. They're identical, so they're each achieving 75% efficiency, but the question is how much is one of them in terms of effective capacity? Oh, this is not the answer, 200,000. That's the effective capacity of all of Kitty Cream. To determine the effective capacity of one of their fry vats, it's a step along the way. You take that number and you divide it by 3. They said they were identical, so to actually answer that question, let me take the 200,000 that I got, divide it by 3. 66,666.6666. There's no such thing as 2/3 of a donut. Well, there shouldn't be if they're going to sell it to you, right? That's how we get the answer to that particular question. The effective capacity of one of the fry vats is 1/3 of the overall effective capacity, 66,667 donuts. Ugh. Now, similarly, this next question, same thing. Small question. You think it would be simple? Just take it in steps. The effective capacity of a system is only 60% of its design capacity. Okay, so here we go again with information about effective and design. Actual output 80, design capacity 300. Now here it does sound like it wants the result of a formula. How efficient is this system? Output over effective capacity. But I need to organize this information here. I know that efficiency is output over effective capacity, and actually the output part is easy. Actual output's 80 a day. Okay, I'm just going to note that to the side. Output's 80. Efficiency, I need the effective capacity. What was I told about effective capacity? The effective capacity, maybe I will write this even as I read it. The effective capacity of this system equals 60%, 0.6, its design capacity. All right, I didn't determine anything here. I just rewrote that sentence as a vaguely algebraic expression. And the reason I did that is because I need this number to then calculate efficiency. Okay, and it says it's 0.6 times this number. Oh, wait a minute, but design capacity, that was given, it's 300. Oh, you don't need design capacity to calculate efficiency normally, because efficiency is output over effective capacity. But in this case, we do need it to track down what the effective capacity would be. 0.6 times 300, I did that, I get 180. That is apparently the effective capacity right there. It's 60% of 300. Oh, okay, finally. The only thing we're doing is just piecing together what we need to fill out that same old formula for efficiency. Efficiency equals output over effective capacity. I always remember effective capacity starts with E, efficiency starts with E. That's how I know which one I'm working with. And now, oh wait, now I have everything I need. It's 80, right? Effective capacity is 180. 80 divided by 180, 0.44, or there's the answer, 44%. How efficient is the use of this system? 44%.